Yeah, we are looking at the homogeneous second order linear differential equation, and is of the form, it is of the form, it is of the form, it is of the form. Second differential plus p of x y prime. This is second differential. First differential, then plus q of x y equal to g of x. So this is a form of second order linear differential equation. Then there are key notes here. Key notes. One, if your g of x is equal to 0, then the equation becomes homogeneous. The equation becomes homogeneous. Homogeneous. Okay. 2. If g of x is not equal to 0, then equation becomes non-homogeneous. Non-homogeneous. Okay, because it becomes non-homogeneous. So then let's look at the key definition. Of this A. Okay, so this is called second ordinary differential equation with constants coefficients. Okay, so this is what we call the it's homogeneous. This equation is homogeneous. You can see is equal to 0. So this is called second ordinary differential equation with constant coefficients. These are the constant coefficients A, B, and C. They are constant coefficients. Okay, so our goal now, our target is to work on this equation, this second ordinary differential equation of C1 equal to 0. To work on this by suggesting, we have a suggestion whereby we have y equal to, suggestion is y equal to rx as the solution. Let it be the, as a solution. Let's call this one equation 1 because we're making reference to that. Let's call that one equation 1. So we have our goal. This is our goal, okay? And there's a suggestion that this one, let it be what? Let it be a solution of this second order differential equation. Okay. So if that is the solution, okay, of this, then we can get the first differential. We can get the first differential of this, which will be equal to. If you differentiate this, that will give you the derivative of the power is just r. So it's r times the function. That's how to differentiate exponential function. Exponential function is always the derivative times the equation itself. You can do it again, get the second differential because you have to get the second differential, get the first differential, and plug in those two differentiation into this. Okay, so that we can get the auxiliary equation. Okay, so the second differential, we'll do it again. The derivative of this is also r times this one. So that will be equal to r squared equal to Rx. So we've gotten um, we've gotten the first differential and second differential. Okay, then plug in this y1 and y2 into this equation one. Okay, plug in that. If you plug in that, then we have a. My second differential is r squared erx plus b times the first differential, then plus c times y. Y is what? Erx. Okay, equal to 0. Equal to 0. Then if you look at that equation, you realize that the exponential function, this one is here, and is here. So we can take it out. We can factorize that. If we factorize that, then we have r squared. We have r squared. We have a r squared plus br, and then plus c, okay, plus c equal to 0, equal to 0, okay, to 0. Then you can divide through by this exponential function. Then you now have ar squared plus br plus c equal to 0. So this one is called this is called auxiliary equation. Auxiliary equation of. This is called auxiliary equation of equation 1. Okay, so that's called auxiliary equation of equation 1. Okay, then the next thing to do now is to find the solution, to find the solution, of equation 1. To find the solution of equation 1, we need the solution. We need the solution. We need the solution of the what? Of the auxiliary equation. We need the solution of auxiliary equation. And if you look at the auxiliary equation, you see that it's quadratic. This is quadratic. Okay. We need the solution of the auxiliary equation, which is what? Which is a quadratic equation. Which is a quadratic equation. Okay, so this is quadratic equation. Okay, which is quadratic equation. Okay, and the solution will be what? Therefore, the solution of auxiliary equation. The solution of the auxiliary equation is, you can have this one, you can call this one r1 equal to minus b plus b squared minus 4ac plus 2a. Then we can have the second one, r2 equal to what? Minus b squared minus 4ac over 2a. So these are the solution of the auxiliary equation, and the auxiliary equation is quadratic. It's quadratic, and don't forget the root of the quadratic equation is minus b plus or minus b squared minus 4ac over 2a, and that's what we split into 2. Okay, as the solution of the auxiliary equation. Okay, we are going to extract 3 conditions here, 3 cases here. Okay, and those cases we're going to look at them. Look at case 1. Okay, let's take case 1. We want to see certain cases here. Case 1, and we are playing with the discriminant here. We're playing with discriminants. Okay, so the case 1 is when your discriminant, which is a b squared minus 4ac, okay, when it's positive, when it's greater than 0. Okay. If your discriminant b squared minus 4ac is greater than 0, then the auxiliary equation, then the auxiliary equation, 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 we have then the equation as what? As distinct, two distinct real roots, two distinct real roots, in the sense that your r is equal to your r. What we mean by that is that r1, you can see the first one, is not equal to r2. Okay, r1 is not equal to r2. Okay, r1 is not equal to r2. Then also equation one, also equation one has two solution. Also equation one has two solution. And this will be equal to no, don't forget, that will be equal to y1 will be equal to e r1 this, and then y2 equal to what? Exponential r2 this. So that's the two solutions. And then the general solution will now be for equation one. The general solution, the general solution will be equal to y equal to c1 over y1 plus c2 over y2. C1 y1 plus c2 y2. So this will now become c1 for case 1. Y1 is what? E r1 times x plus c2 e r2 times x. So that's for case 1. So that's for case 1. Then case 2. Case 2 is when we are looking at the discriminant, which is b squared minus 4ac is equal to 0. Okay, when your discriminant here, this one 4ac is equal to 0, then the auxiliary equation, has the auxiliary equation, then the auxiliary equation has the auxiliary equation has repeated roots, has repeated roots, whereby r is equal to r1 equal to r2. R is equal to r1 equal to r2. Okay, so in that case now, the okay, also as what? As two solution. As two solution, which will be y1 be equal to e. No, your r1 is equal to r2, so it's equal to r. So that will be equal to e rs, and then y2 will be equal to what? X e rx. Okay, that's for the repeated roots. Okay, then the general solution for equation 1 for your second order differential equation will be equal to the general solution will be equal to c1 e rx plus c2 x rx. So that's the general solution for this. Okay. In addition to that, to this one, that equation has one repeated root. You can put that one there. Has one repeated root. Has one repeated root. Is situation case 3 is a situation where your discriminant is equal to b squared minus 4ac. But in this case now, it's less 0. Okay, your discriminant is less 0. So that will be what? Then the auxiliary equation has what? Has two distinct complex roots. two distinct complex roots. Okay, and that will be equal to, and that will be equal to, um, um, if you got case, we're having alpha plus or minus beta I. So that's it. So we can break into two parts. So the R1 will be equal to what? Alpha plus beta I. And then the R2 is equal to what? Alpha plus this. Okay, minus this. What does that mean? This, the real part will be um, this is the real part, okay, which is an integer. It could be positive, it could be negative, it could be zero. So it's basically integer. That's the real part. And the beta will be the angle of that function. Okay, the complex part will be the angle of that functions. Okay, so that is just that. So then we can get the solution also. The equation one, equation one also has what? Has two solutions. Question 1 has two solutions. And let's see those solutions. The y1 will be equal to e alpha x cos beta x. Okay? So whatever the attachment of your complex number, that's your beta. That's your beta. Okay? Then y2 has what? E this and then sine this. Okay, so that's just that. Where the real parts of that complex root will be is there. Okay, the complex part, the coefficient of your complex number is your beta. So that's that. Then the general solution for equation one, the general solution, the general solution, the general solution, the general solution is y equal to C y1 plus C2 y2. Okay, and then we can plug in those values, and that will be equal to C1. Your y1 is what? E alpha x cos beta x plus C2 E alpha x sine beta x. So that's that on these on those three cases. So that's that on three cases. So the next thing we're going to do now is to look at applications, look at questions, and see case one, case two, in the, case three for those questions. Okay, please join the next video for applications of all those cases.